Hi everyone. So this is a circle theorem called the intersecting chord theorem, and it's based on using similar triangles to find a relationship between the length of two chords. Now, quick recap, similar triangles, the angles have to be the same in each of the triangles, which means that the sides are in the same scale factor. So if I started with these sides, I'd have to times them by the same value to create the larger ones, or I could start with the longer sides and multiply them together, divide them by the same value to get the smaller one. That means that they have to be in the same ratio. So if I did the capital letters all divided by the lowercase, I would get that same scale factor. And that means that the sides are in the same ratio, therefore they're similar. Now we can use this relationship along with one of our previous circle theorems, which is, some of you call it the bow tie one, but these are angles in the same segment. So if I draw this line across here, we see that the angle at D is the same as the angle at A. And if I drew a different dotted line to split the circle up into two different segments, I would get that C is the same as B. Now, I've highlighted the sides that are the same or correspond to each other. So this triangle is smaller, OCD. This is the larger of the two triangles, OAB. Because OD and OA lie between the same two type of angle, I can divide those to find the scale factor. So I'm going to take the larger of those two sides, which is AO, and divide it by DO. And I'm going to repeat that for these two sides that must also be in the same scale factor. So the larger of those two is BO, and the smaller CO. Now, these sides would be in the same scale factor, but we're only interested for this circle theorem of the intersecting chords. They're the ones that we're interested in. And with a little bit of rearranging, of timesing through by the denominator, we get our intersecting chord circle theorem. And it basically means that if you times together the two sides, so here I've got CO and AO, so times this length by that one, you get the same value as if you times together BO and DO. Right, it's a really nice little circle theorem. So what would that look like in terms of an example? Well, here I'm going to do 4 times by 12 because they're the two sides here of my intersecting chord, and that has to be equal to 8 times by x. So I end up with 48 equals 8x, so x has got to be equal to 6 centimetres. Okay, so pretty simple really. You're just timesing the two sides of the chord together and they have to be equal. What's maybe not as obvious, and I'm going to show you on GeoGebra, I'll just go into this link. You've got this link. If I move this, I'm just going to move it so that the chords do intersect. Right, so that's the kind of question that we did have. But theoretically, you can move these points on the edge of the circle so that the intersection gets closer and closer to the circumference. Now, if it's on the circumference, that means that you've got 0 times by these two. So they're both equal to 0. Okay? Because there's no length the other side of the intersection. But you can extend this circle theorem so it crosses over. So we might have something that looks like this. And we can see now that we've got OA. In fact, I'm going to take a screenshot so I can draw over this. Let's put it in here. Put it at the bottom. So we've still got the same circle theorem, but now, because the intersection is outside of the circle, we have to do the whole length multiplied by the distance to the intersection of the circumference. So if we look at this top line here, I've got OA, which is the whole of that line, times by OB. And then here I've got DO, I've got all of that line times by this. Okay, so it's still, you're still using the same circle theorem, it's just the whole length and then the distance to the circumference from the point outside. So let's put that into practice. So this top line here, the whole of that length is 16. The distance from the point outside to the circumference is 6. So that's got to be equal to the whole distance, which would be 8 plus x times by 8. Okay, so I'm not going to expand the bracket because I can notice that if I do 16 times by 6, I get 96. And that is a multiple of 8. So if I divide by 8, I end up with this. And then I can subtract 8 and I've found that missing value. Okay. I hope that's helpful, and there's a link in the task as well to the GeoGebra page so you can move it around and have a little look at it. Questions to do and answers attached. Any questions, please send me a message. And yeah, get those done by Monday so that if it does come up on the test, you are prepared. See you later.